In this video, we'll talk about half wave without a capacitor. I've uploaded a video on the half wave with a capacitor, and here is the half wave without a capacitor. So that means it's a rectified half wave. Rectified half wave. Then that one, it was filtered half wave. Filtered half wave. So a filtered half wave, a filter is when there is a capacitor on a second. Then when there's no capacitor, it's called rectified half wave and half wave. Then when there's a capacitor, it's filtered half wave rectified. So now it's just a rectifier half wave. There's no it's because there's no capacitor on our second. So on this second, we were asked to calculate average voltage, which is DC voltage of the circuit, and IRL, which is the current through RL, PIV, peak inverse voltage of the circuit. So we are asked three things. We have to calculate three things for the question. The question we asked for three things. Find the VDC, find IRL, and peak inverse voltage. So first question, find VTC. VTC is the voltage, is average voltage, which is the voltage across the load resistance. So how can we get IR? How can we get the voltage across the resistor? So testing test. These questions, it's like they summarize the questions. They're supposed to ask us V peak, V sec, V peak out, then we'll be able to get our VTC. So before we get VTC, we can't get VTC without V peak out. We can't get V peak out without V peak. We can't get V peak without V sec. So it's step by step. Question says calculate VTC. And we know that we can't get the VTC without V peak. We can't get VTC without V peak out. And we can't get V peak out without V peak. We cannot get V peak without V sec. So that means we'll have to calculate V sec, V peak out. Then from there, we'll get our VTC. So now let's see how we're answering these kind of questions. First thing first, we need V sec. The formula for V sec, we all know this general formula. The general formula says that NP divided by V primary is equals to NS divided by V sec. So primary, what is the primary? Primary is this side of the transformer. This side of the transformer is primary, and that side of transformer is secondary. And these numbers here is the number of turns in ratio. So it's 16 by 1. So when the number of turns in primary, they are greater than the number of turns in secondary, that means your type of transformer is a step-down transformer. Our transformer is a step-down. Why? It's because the number of turns in primary, they are greater than the number of turns in secondary. That makes our transformer to be a step-down transformer. Let's continue. So from this formula, we are looking for V secondary. So we'll simply cross multiply and make the V secondary subject of the formula. So if I make the V secondary subject of the formula, V secondary is equals to V primary multiplied by number of turns in secondary divided by number of turns in primary. Divided by number of turns in primary. So what is the V sec? The V sec is going to be 220 times 1 divided by 60. 220 divided by 16. Our V secondary is 13.75. 13.75 volts. Please don't forget the units. Always put the units because they might penalize you for not putting the units. So V secondary is 13.75. Now remember we need now let's get what? The V peak. Let's get our V peak. Formula for V peak is equals to V secondary multiplied by square root of 2. So the V secondary is a V max. V secondary is a V max. But here we use the terminology of V peak, not V max. But then V secondary is the same as V max. So what is V peak? Our V peak is 13.75 multiplied by square root of 2. It's equals to 19,445. It's equals to 19,445. 19.445. I round off to 3 decimal places, the minimum. So I have VSEC, V peak. Remember, the formula. What is the formula for VTC? The formula for VTC is equals to V peak out multiplied by 0.318. It's V peak out times 0.318. That is the formula for VTC. So that means for us to get the VTC, we need what? V peak. And we know that to get the V peak out, we need the V peak out. So for us to get the V peak out is equals to V peak minus 0.7. So V peak out is equals to V peak out is equals to V peak minus 0.7. And we know that from V peak out, we can easily get our VTC. That's the only formula that can help us to get VTC on this question. We can only apply this formula or the formula that is similar to this one. But our formula is going to require us to use V peak out to get the VTC. There is no other formula that we can use to get the VTC without the V peak out on this question. So that means the only way to get the VTC is to get the V peak out first. Therefore, we'll have only one unknown, which is VTC. So you see from VSEC to V peak, from V peak to V peak out, from V peak out to VTC. So it's step by step. But then the question we were asked to get the VTC only. You will find out it's 5 marks. So someone who doesn't know won't apply this. We'll just apply this formula and we'll just try not to use the 220 or the VSEC. Because like sometimes you find out it's 3 marks, but then we used 4 formulas to get the VTC, but then it's 3 marks. So the marks doesn't determine the step they are going to use. Always the step you might use many steps, but you find out the marks they are less. So don't compare with the marks when you're answering this kind of questions. Always when you're answering a question, don't compare your question with your marks. Always work or do the calculations as long as you know you're doing the right thing and you understand what you're doing. Don't check whether the marks are less or they are more. So now we have the V peak out. The V peak out is equal to V peak minus 0.7. Someone will ask me why I'm saying V peak out why is V peak out is equal to V peak minus 0.7. So let me just explain it. Why is this formula like this? Here, the V peak is the voltage. Is the voltage that is going to enter on the diode. Is the V peak. Is the voltage that will enter on this diode. Therefore, the V peak out is the voltage that will leave on the diode. So the V peak out is the voltage that will leave the diode, and the V peak is the one that is entering the diode. And the diode has its own voltage, which is 0.7. The diode has a voltage which is 0.7. So V peak is entering, and V peak out is leaving the diode, while there was a voltage across the diode, which is 0.7. So that means the V peak out is the voltage drop across the diode. A voltage drop is like we're supplying and you lose some voltage across that component that you're supplying, then the output voltage is called a voltage drop. It's a voltage drop. Why? It's because it's a voltage drop because you supply the input. After the input, you lost some voltage across a component. So that voltage is called a voltage drop. So the V peak out is going to be the voltage drop across the diode. So it's the voltage that we got after losing some voltage across the diode. So it's like the output voltage of the diode. We received V peak and now we get V peak out. We received V peak, at the end we get V peak out. So the V peak out is the output voltage of the diode. E.g., we have 5 volts and 2 volts here, and then what is the output voltage? Now, what is the voltage at the end? Let's use maths and general knowledge. What is the voltage? This output voltage. I'll put the zero. This zero will determine V out, which is the output voltage. You are supplying 2 volts, positive 2 volts, and then the component that you are supplying has its own voltage, which is 2 volts. What is the voltage at the end? Symbol is going to be 5 minus 2. Then your output voltage will be 3 volts. It's like this. This is V peak. Sorry, it's like this is V peak, and this is the voltage across the diode, which is the V diode, and this here is your V peak out. So that's how V peak out is formed. You can derive it. You can derive it. You don't need to memorize it. You can derive it because sometimes you'll have voltages on a full wave. So you need to know how to derive V peak out. Some of the formulas you can derive them. You don't need to memorize them. You just need to understand the flow of current. So that's how the formula V peak out was found. That's how it's found. So what is the V peak out? It's 19.445 minus 0.7 is equals to 19.445 minus 0.7. Therefore our V peak out is 18.745 volts. So that's our V peak out. Remember the question, we were asked to calculate what? VDC. VDC, which is the average voltage, which is the voltage across the RL. So now our formula for V peak is this one. V peak is equals to, VDC is equals to V peak out times 0.318. V peak out multiplied by 0.318. We peak out multiplied by 0.318. So the 0.318 is constant. Is constant. The 0.318 is constant. This formula just need to memorize it. You can't derive it. It's going to take us long to memorize this formula. So 0.318 is constant, and then we peak out. We have it. Then VDC is the one that we're looking for. So VDC is equals to 18.75 multiplied by 0.318. So what is the VDC? Now the VDC is equals to 5,961. VDC is equals to 5.961. So since our VDC is 5.961, we'll simply write it there. I want to say something. So guys, the resistor, it doesn't use V peak out nor VTC. Doesn't use V peak out nor V peak. The resistor is going to use VTC. VDC, DC voltage. It's not going to use the V peak out. So the resistor is going to use VDC, not V peak out, not V peak. The resistor is not going to use V peak out or V peak. That's why we are converting the V peak. The V peak, it's in AC. That's why we're converting it to DC. Now in DC, it's 5.961 volts. So IRL is equals to VDC divided by RL. So what is IRL? IRL is going to be 5961 divided by 470 is equals to 5.961 divided by 470 divided by 470. Then our current is 12.683 milliamperes is 12.683 milliamperes. Look, it's a small letter m. Small letter m represents milli. In engineering notation, small letter m represents milli. Then a capital letter M represents mega. Mega, which is 10 to the power 6. Milli is 10 to the power -3. I'm using engineering notation. So PIV. PIV is peak inverse voltage. Peak inverse voltage, PIV is equal to Vsec on a half wave. On a half wave, PIV is equal to Vsec. Therefore, our Vsec, what was our Vsec? Our Vsec is 13.75 volts. Our Vsec is 13.75. Therefore, our Vsec is 13.75. So that's PIV. So we were asked to calculate or to find or to answer these questions. Look, the calculations. So the questions and the marks, actually the marks doesn't determine how many steps you should use. Calculate and use the steps that you're used to. Stop doing shortcuts. Stop doing shortcuts. Sometimes they want to see all the steps, but for 2 marks or 3 marks. So always show them all the steps. So that was it for these questions. Please, if you understand or you don't understand, if you don't understand, comment. Tell me where you don't understand. If you understand, please subscribe, follow, and share. Don't forget to turn on the notification bell to stay tuned for new videos that will be uploaded. Thank you.